It is part 2 of lecture 1, week 1. We will explain transmission medium. What's the transmission medium? Between transmitter and receiver, we said we have a transmission medium or we have transmission channel. So transmission medium is divided into two parts, which is guided or wired, or we have wireless or unguided. What is mean of wireless and wired? It may be very clear for all of you. You have wireless channel. It means we don't have wire between transmitter and receiver. Like when we use mobile phone, we don't have connection with our router. We don't have connection with the towers which we communicate with. So we have a wireless and a wired signal like a twisted pair or a coaxial cable or optical fiber. It's a optical fiber, this one, which is transmit light signal. Also, you have coaxial cable when usually use it with TV and satellite. Also, we have twisted pair. Some twisted pair it use it for PSDN. PSDN communication system, which is we say in normal or something like that in our language. So guided wave is classified into 3 different type, like twisted pair, coaxial cable, and optical fiber. Also, wireless signal, which is not wire between transmitter and receiver. In simple word, we have radio wave, you have microwave, you have infrared wave. What's the difference between radio wave and microwave and infrared wave? Basically, is the frequency range. The frequency range of infrared is much greater than microwave, and microwave much greater than the radio wave. As we see in this picture, the mobile phone is wirelessly connected with base station towers, and there's a between routers of internet communication system. We don't have a wire, so it's called it wireless. And wireless signal or different type of signal are classified according to their frequency range. We have different frequency range, and we have different property for each frequency range. The frequency, the different type of medium, like for example twisted pair cable, it support very low frequencies, like 1 kilohertz to 100 kilohertz. And later we have coaxial cable, which support also very low frequency range. It is used like for applications very low frequency range, or it is used for coaxial cable, it is used for medium frequency range or high frequency range, and so on according to the graph. Also, waveguide is used to different frequency range. I missed it to explain this side. This side, it represent what's in this number is. For example, we have wavelengths which start from 1 centimeter, 10 centimeter, 1 meter, and 10 meter. When we go in this direction, the wavelengths will be increased, and we have at the opposite side we have frequency. When the frequency increases, the wavelengths will be decreased. So any communication system is separated from different frequency system by its frequency, and based on this frequency range, we can use different type of medium. So twisted pair use it for low frequency, coaxial cable a bit higher, and waveguide for very high frequency range, and optical fiber, which is different from waveguide and coaxial cable, use it for sending by a light signal, which is very high frequency range, and it is not electromagnetic signal, it is just a light signal. Also, we have a laser beam, which is a very small application in communication system. Also, in terms of propagation mode, we have different propagation mode. We have ground radio wave, we have sky radio, also we have line of sight. Also, it is go to laser beam. And ground wave, for example, use it for this range of frequency. Sky wave use it for this range of frequency. Also, line of sight is used usually for radar or satellite or microwave relay air station. That is what explained in this slide, which is too much information in this slide, so we have to be aware about that. The wavelengths and frequency have a different range. When the frequency increases, the wavelength is reduced. Also, the application for each type of wired channel or wireless channel have in different frequency range. Now we go to analog and digital system. Previously we explained it, what's the difference between digital signal and analog signal. Now we speak about the systems. What's the analog and what is digital system? Analog system process analog signal which can take any value within the range, and audio amplifier is an example of analog system. The amplifier produce output voltage which can be any value within the range of its power supply. All like this clock, we have different value for this needle. For example, we have 1.1, 1.111. So whatever we pick, we can see the smallest signal and smallest signal and smallest signal. But for the digital system, like this digital, we have only, for example, 2 point in the after the decimal number. For example, it is 9 hour or 9 o'clock 51 minute. What about the smaller than 51 minute? Sometimes we don't have, but in analog signal we can see the precise and detailed information. But most of the communication system nowadays are digital systems. Take an activity about 10 minutes, discuss the advantage and disadvantage and wired and wireless transmission medium. As we explained it, we have wired signal and wireless communication system or wired channel. What are the advantages of each other? Explain and compare them. Compare analog and digital system or digital communication system. Discuss their benefit. Discuss the advantage of analog signal. Also discuss the advantage of digital communication system. Now we go to the another term which is called efficiency. What's the communication system efficiency? We know that if the efficiency is increased, it is very important and good for communication system. Maybe it is general information, but what is the efficiency physically? Physically, yeah. What's the physical meaning of efficiency? We can relate the efficiency into some term like quality of receiver signal. Compare RT to ST. When we have a message signal, ST, this signal will be transmitted. At the receiver side, we receive RT. If we get exactly the same signal as ST, so you have very high efficiency. If the quality of RT signal or the receiver signal reduce it, so the efficiency will be reduced. Measured by signal to noise ratio, SNR, which is analog, or bit error rate, or which is say BER. Also need high quality of transmission. So by this parameter, we can compare between transmitted signal and received signal. We can find one of the terms, one of the criteria for measuring the efficiency. Also, power needed to transmit modulated signal. Low power, lifespan battery is longer. High power, lifespan battery is shorter. If we use lower power, it is better because we have longer lifetime of the battery. For example, for your mobile phone. Also, we have a bandwidth needed to transmit a modulated signal. Low bandwidth mean more user can share the same communication system. Whatever you use lower bandwidth, it is more or higher efficiency for our system. Also, quality of signal need to transmit. Analog signal depend on the signal bandwidth. Digital signal depend on the bandwidth and bit rate, which is bit per second. So this parameter is for explanation what's the efficiency, how efficiency can be increased, what's the function of communication engineers to improve the efficiency of any system. In communication system, sometimes we have some obstacle which draws the efficiency or reduce the efficiency. What are these? Technology problems like hardware, economy, law, and regulation. These affect the efficiency. Sometimes if we wanted to increase the efficiency, it cost more cost, which is not allowed by some companies, or is targeted to use as possible low cost, so which reduce the efficiency. Also hardware, some hardware is not support high efficiency because they have losses, so also it is problem of communication system. Also some law and regulations, as we said, we have ITO, communication or international organization which produce different standards. According to this standards, some standards reduce the efficiency of your system. Also we have some physical problems with like bandwidth, signal power, and noise, which will be explained what's the effect of each this term in our communication systems.